Okay, so on the very last page of your report, instructions for your report. Maximum, very last page, 4 students per group. Include all the names on the top page. You will turn in only 1 report per group. The report should be written on a new piece of paper. So I don't want to see the lab form turned in with all the answers on it, because I'm not going to accept that. You may cut out the graphs from this handout and paste them into your report. Your report should be clearly written, not just chicken scratch, and should be put together like you would a formal lab in science. Okay, so I've seen a lot of like pieces coming in, and that's not okay. No, you can write it by hand. If you have an Inspire calculator, you have the software, but you can get the software for free anyway, for 30 days. And you can just put it, you do. Where'd you get your calculator? You can get it for free for 30 days. Anybody can get it, and it does all, you don't have to do with math fonts, but it does all that, and it does all the graphs, and you could just actually put in one big report and just print it out, and then you could write in the other things. But there's a notes page, which is nice and easy to write in on the computer. It's up to you, but it should be nicely presented. It shouldn't be a mess. You shouldn't have to look for things. Everything should be clear. If you write a sentence, make sure it's a complete sentence. You do have to answer some questions. There's not a lot of questions where you have to write things verbally, but please use complete sentences. You should include a sample calculation. If you're doing any kind of a calculation, you should give me a sample of what in the world you did. And you don't have to do it 5 times. You have to do the calculation 5 times with different numbers. Just give me one sample, and then give me all the answers after that. And if you do not follow these directions, your report will be returned to you to make corrections. So we don't want to be in that boat. Okay, so the goal today is discovering the derivative. Okay, we are going to develop the definition of the derivative of a function at a point by examining the slope of a secant line. And you should have all had an anticipatory guide. You probably don't know what a secant line is. In a circle, what's a secant line? This is a secant line. Cuts through the circle in 2 spots. Do you remember what this is called in a circle when it just touches like that? No, that's a chord. Okay, so this is a secant. I don't think it's related to the secant of the tree, but and then if you talk about touching in just one place, that's a tangent. And something you need to know about tangent lines, it might prove useful in this class, is that a tangent is always perpendicular to the radius in a circle. I'm thinking of the quiz. Particularly, that might be useful. Okay, tangent touches in one place. You are going to zoom in on your secant line, and you're actually going to take a curve and you're going to drag a point. So you're going to have a secant line like this, and you're going to take this point, and basically what you're doing is dragging it along the curve here, getting closer and closer and closer to the tangent line. You can't find the slope of the tangent line because there's only one ordered pair. So you're going to have to look at the limit. So that's what you're going to be doing. Okay, so define the slope of a function numerically by using the n-derived function on your calculator. We'll go over that. I'll go over the 83 method, or the 84 method, and the Inspire method. There's 3 different things we have to look at. So whatever calculator works for you is what you need to pay attention to. And then, in summary, there are 3 approaches for each problem. There's the geometrical. That's the zooming in. That's where you keep zooming in on this line, at this curve. You keep zooming in at that point, and you get closer and closer. What's going to happen to the curve? It's going to look like a straight line. Make sure that when you zoom in, you get it to look like a straight line. Because some of you will not zoom in far enough. You need to be close. Okay, we're going to do geometrical. This is the easy part. You just zoom, find 2 points on the curve, and then find the slope. The next one is the analytical. That's the hard one. That's the algebra. And we will go through at least one of those. That'll look like what we did in Chapter 2. And then we're going to use the calculator. And it's called a numerical solution. And basically it's the same as the geometrical, but the numerical is going to be using your calculator, and you don't have to do any work with it at all. You just have to know how to use the syntax on your calculator, plug it in, and then it'll give you a number. Okay, so number 1, let's look at that picture. Make sure we have this down. Did you get 1 correct? Okay. I don't know where you're at, because I started. Now, if you need me to start all the way from the beginning, watch Pre-2, because I went through the whole thing. And you're zooming, okay, and you found, now number 4 is really 3. I'm sorry, there's a typo there. So 3, you have this nice, beautiful picture, and that's 3A, that chart. And you can cut that chart out. You could also cut it out of the Word document that's online if you wanted to type it up and make it look pretty. Doesn't matter to me. It's just up to you. And on 3A, or 4A, which is really 3A, sorry, you're going to find the slope between 1 and -2, and then you're going to do 1 plus h. The very first point is 1.6, and then it's f of 1.6. I don't know what that is, but you're going to find the slope, and this will be your sample calculation. It's f of 1.6, and you must keep all the decimals that are there. Do not round or truncate in the middle of the problem. So you have to keep all of them minus, and it's going to be -2, right? All over 1.6 minus 1. And that's your h value, isn't it? H was 0.6. What's 1.6 minus 1? 0.6. That would be your sample calculation. Once you do that, you can just go ahead and find all the rest of those numbers. And I can do that pretty easily with my calculator, too, and just substitute some numbers in there. I don't know if you want me to show you how to do that or not. Have you got those numbers all calculated out? Okay. That's kind of cool, because if you were to do this, if you put this in y1, all you have to do is y1 of 1.6 plus 2 over 0.6. Then all you have to do is go in and change this number to 1.4, change that to 0.4. You know how to do that on your calculator? By going to the second entry. It saves you a lot of time, but that's just a calculator. Okay. Then on B and C, you're going to try to answer the questions. And what it's asking you is if you have this graph here, and you have this point, and now you have your secant line, right? Grab that. So your secant line goes like this. What happens as you drag this point down here? You get another secant line. And you drag it even closer. What's happening to H? What's happening to H? Not going to let me grab that point. Behind it. What's happening to the distance between this red point and this blue point? And it's going to zero. What geometrically is happening? The secant line is doing what? Getting closer and closer to the what line? Tangent. Don't make things complicated. That's all it's asking you. And you want a limiting value. Now the notation for this limit that we just did is called a derivative. And it's f prime, and that's the point in question. This point that you're looking at. So that f prime is what it actually is finding out, and that's the derivative, which is the slope of the tangent line. And there's another notation. So my presentations in this class and the other class are quite different. So if you need a step-by-step go through all the pieces, I've got that in the other class. But the slope of tangent line, there's another notation. It's called dy dx. And if you think about it, it kind of looks like change in y over change in x, doesn't it? If you made the delta a d, then you'd have dy dx. That's also another notation for slope. So you have f prime of x, and you have dy dx. The one here. Delta y over delta x is a rate. And now a rate is a ratio or a comparison of two things. It's a rate of change. So I'm comparing two changes. And when you get into the calculator piece, I'll explain what that means, because that's really important. So when you're looking at a slope, is how does the y value change as the x changes? That's critical to this class. To start understanding, you have to talk about how the y changes as the x changes. What if I change position as time changes? What is that? Change in position over change in time. So here in physics. Change in displacement as time changes. So as time goes by, I cover a certain amount of distance. And you guys all drive cars. That's called your what? You drive a car, you look at the speedometer, that's the change in position over the change in time. It's your velocity. Yeah, it's your speed. Actually, we'll talk about velocity. Speed and velocity are a little bit different because this is a vector. We have to worry about that. Okay, so you don't get to drive a car unless you know what a speedometer means. You're going 50 miles in 1 hour. That's how much distance you're going to cover in an hour. So when you look at the racers and how fast were they going? You guys saw the horrible accident, right? 200 miles in an hour. And a plane goes how fast? That's a pretty fast plane. About 450, 400. But once it gets up there, it goes at a constant speed, but going up and down still. Okay, so how about this analytic thing? The analytic slope. There are three things you're going to have to do. You're going to do this geometrically. That's the zooming. And then you're going to do things analytically. So we really do have to go back to page 1, problem number 1. And what is the slope here? This is A. See what you guys tell me what you have here. I'm going to go over a certain distance. I'm going to call that distance H. I'm going to go over that distance. So now I'm at A plus H. What's this ordered pair up here? This is f of x. I want to find the slope between these 2 points. This is the very first page you said you didn't need. It's A comma what? F of, not x, f of A. That's not too bad, right? This is A plus H, and then this is F of A plus H. And what did you find for your slope? Well, we know this, right? F of A plus H, there you go, over A plus H. I'm going to make it obvious. You're right, that's H. But you see slope now. When I write it as H, I don't see slope personally. Okay? And then what are we going to do with our function? Our function is f of x is equal to x cubed minus 6x plus 3, right? And we're going to go through the ordered pair 1, negative 2. We're going to go only a little bit of a distance to the right. We're going to call it h. So what are we going to do this? What are we going to do with this analytically? We're going to find the slope between 1, negative 2, and 1 plus h, and f of 1 plus h. Is that okay, Natalie? Okay, so what are you going to get? You're going to get f of 1 plus h minus f of 1 all over h. And what are we going to do? We're going to drag those points closer and closer together. So we're going to take a limit. And what's going to happen to h? The distance between a and a plus h. This point's going down this curve here. What's happening to h? No, h isn't going to a. H is going to 0. Because h is the distance between these 2 points. That distance is getting shorter and shorter. Does that look familiar? Did you do your homework in chapter 2? Yes. We did that, except we had a c there, didn't we? Remember those limit worksheets when we had f of c plus h minus f of c, and we did cubics and quadratics? Okay, well guess what? We're going to do this for this function. And let's go ahead and substitute it in. So it's the limit. Now, the problem with this is the bookkeeping. So in place of x, I'm going to put in 1 plus h. So it's 1 plus h cubed minus 6 times 1 plus h plus 3. That's f of 1 plus h. you probably should write this down. I'm going to do it for you, and it'll be done. Because this goes in your report. This is the analytic piece. So go down to the says analytic slope. Using f of x algebraically, find the slope of the tangent lines. Include a picture. You must use the limit of a derivative. This is exactly what you write. Minus f of 1. And this is all over. Everybody should be, actually. Because everybody's responsible for this. No matter who's writing the report, you're still responsible for the material. And what's f of 1? -2. And if you remember, I promised you, and I don't take promises lightly. I'm going to promise you only if I can assure it. And if you do your algebra right, I assure this. If this -2 is going to go away, things will always cancel out. The thing I really like about math is it tells you what to do. Once you've got this part right here, this is just slope. The calculus is saying, I want those points to go closer and closer together. The rest of this is algebra till we get to the end of this. But it tells me what to do. If I substitute in h equals 0, I'm going to get what? 0 over 0. Because you can't find the slope at a single point. It doesn't make sense. When I can find out what it's getting close to, and that's what a limit is. What's it getting close to? So I have to know how to cube out that 1 plus h. So it tells me what to do. I don't know what else to do but say, oh, I could expand that. And if I have a CAS calculator, it'll do it for me. So you might want to put friends who have CAS calculators. But in the meantime, those of us who don't have to know how to do this. So a plus b, now I'm not going to use 1 plus h, make you do a little work, to the 0 power is 1. A plus b to the first power is 1a plus 1b. Remember Pascal's triangle, and you've seen it before. This is the binomial theorem. And then when you square it, you have to FOIL. A plus b squared is 1a squared plus 2 times a times b plus 1b squared. Or 1, 2, 1. Now, do you remember how you get to the next line? You take 1 and you add these. 3. 2 and 1 is 3. 1. Now, those are just the coefficients. Those are just these numbers right there. That's why I wrote them down. So what is a plus b cubed? Well, we have the coefficients right here. This is the binomial theorem, so you're getting an extra math lesson out of this. It's a plus b cubed. So it's 1a cubed. There aren't any b's. Plus, and then the next coefficient is going to be 3. The a's are going to go down, and the b's are going to come up. So it's a squared, b to the first. And these numbers always have to add to this 3 here. Plus 3. A's are going down, b's are increasing. A's go away. It's a to the 0, and so it's 1, b to the third. And there it is. So do you have a problem with doing 1 plus h cubed? What's that going to look like? So what's 1 plus h cubed? Well, it's going to be 1, and then what's a? A is 1, what's b? H. So it's going to be 1 plus 3. Well, 1 squared is just 1. In the other class, I actually wrote it out. I think that made it more complicated. And then it's going to be 3, and it's going to be 1 to the first power, but this is 1. H squared plus h cubed. We don't want that. H cubed. Okay, so then we just substitute it into our formula. Be careful. I'm going to actually copy this. And you guys should be ahead of me here. You should be doing this, not just watching. And there's a formula. It tells me what to do. But don't forget to put everything in that you need. Because that's easy to forget to do. Okay, so it's the limit. As h goes to 0. Okay, 1 plus h cubed is what I have right up there. 1 plus 3h plus 3h squared plus h cubed. And then I can't forget the rest of it. Where do we make mistakes? By forgetting this piece right here. And it's going to be what? Minus 6 h plus 3. Oh, it's not that bad. And this is plus 2 all over h. It tells me what to do. And now what I'm going to do is simplify that numerator, because I can't think of anything else to do. You can't cancel the 2's. Well, you can't guess the 2's because that's an h, but you still can't cancel it if it wasn't 2. You can't cancel the h's because it has to be a product. It has to be multiplications. But we can go ahead and add some things. Like, what's 1? Take away 6, adding 3, and adding 2. That's 0. Remember, I told you it would go away. And then we have some more similar terms here. I have a minus 6h and a plus 3h. So I'm going to go ahead and add those. So I'm going to get the limit. This is all algebra. What's 3h minus 6h? Okay, and it's really a matter of bookkeeping. It's all it is. Keep track of everything. Don't be sloppy. Plus 3h squared plus h cubed all over h. If I didn't have an h in every term, I would have made a mistake someplace. Now, I personally like to divide the h into the numerator, which means it needs to go into every single term. But you guys don't like that, so we'll go ahead and do that. It's the same thing. So it's negative 3 plus 3h plus h squared all over h. There's the whole. That's the 0 over 0 right here. So as long as we're not at 0, we can do this. Substitute now for the calculus. All of that was algebra. Substitute h equals to 0. What's the answer? Negative 3. This is the definition of a derivative. We're going to be doing this for a while, and then we're going to say there's got to be an easier way, and there is. To challenge you to figure out what it is, though. Because on the exam, they will give you a limit that looks something like this, and you don't want to do it. You want to say, oh, that's just the derivative of. You recognize the function, do it with the shortcuts, and you're done. It's easy. But if you just see this on the exam, you're going to freak out and say, I don't know how to do that. We'll get you some practice. Okay. That's what we mean by the analytic solution. Analytic slope, shouldn't say solution. Now, how about number 5? We'll go back to the numbering on here. Using your calculator for the n-derive command. Now, I got to do this 3 times because we have 3 different kinds of calculators in here. Okay, I put my function into y1. Now, I always put my function into y1 because if it's a complicated one with parentheses and stuff, then I'm going to mess up my parentheses. Now first, let's graph this. I also want to clear my drawing because I want to show you what we did here. I'm going to draw some stuff, and I just want to clear it. Okay, clear. Now, on my window, what I did was I zoomed. What do you mean? No, calculus. Calculus. Well, I'll get there. Okay, guys, ready? Okay, I graphed it. I zoomed forward because I get nice numbers. I like nice numbers, but I don't get the top of my graph. Now, be careful if it's the exam and they ask you to put a graph, and they have, and you do this and you cut off the top, they will mark it wrong because it's wrong. So I'm going to change my window so I can see the top of that graph. No, window. So I did zoom decimal. That's what I did. And I'm going to make this negative 10 and this one 10. Doing great at that. Okay. Ready? I would like to find the slope when x is 1. Well, there's a way to do this. You've seen this second calculate, and you know how to find values and zeros, prime max and mins, and intersection, but you don't know what 6 and 7 are. Now you do. 6 is dy dx. That looks like delta y over delta x, and that's exactly what it is. It is the slope of the tangent line. And now I'm going to type in not x equal to 0, I want it at 1. Now the downside of doing this graphically And there's the downside. Is that if you don't have the right window, you're in trouble. You have to have the right X window and the right Y window. Well, yeah, you have to have the right Y window. So that's the problem. But there's something else cool that you can do here. You can actually draw the tangent line. Ready? Now, see where draw is? It's right above the word program. Grab your calculator's out so you see it. Second, draw. I want to do a tangent line. So you can draw vertical lines, because vertical lines are not functions. But a tangent line is 5. And I want to do that at 1. I'm going to pretend it was not at 1. Type in 1. Press enter, and there's my tangent line. And so that's with the graphic screen. I don't use that often, but this one's kind of nice. It gives you the equation of the tangent line, and sure enough, there's your slope. We should all be able to read the slope. It's the coefficient of the x-term. And in the last class I said, would you do that again? And I said, okay. Let's draw it at a different one. Let's do it at 2. So I'm going to do second, draw. Now, it won't clear it out unless I clear my drawing. Tangent line, and we'll do it at 2. And there it is. There's the tangent line, the slope at 2. Well, the problem is, sometimes, now here's what I've got to do this like 3 ways. The problem is if you don't have the right window, this isn't going to necessarily work. So we have to have another way to do it. The other way to do it is on your home screen, and it's called nderive. And the syntax, how you put it into your calculator, if you're an 83, even an 84 user, you'll try to type it out this way, but 83 for sure is your function, and you have to talk about how the y changes as something else changes. So we're going to change x and see what happens to the slope as I change x along my curve. So it changes. And then you're going to say, well, where do I want to do this? In this case, that's at 1. I put this into y1 because I get all confused with parentheses. This is not a hard function to do with the parentheses, to be honest. Now, what do you see on your calculator? Here's the problem for me right now is I've upgraded my 84, and you aren't going to see what you would like to see. Now I'm going to press math. So everybody will do this. See a 7 that's got a little arrow that says there's more. And so I'm going to go down. It's the next one. It's 8. Okay, so there's nderive. Press enter. And if you have an old 83, you don't see this. You see what I just typed in, wrote in, not typed. You're going to have to do it this way. If you have the new one, you're going to do what, and I can't show you what it looks like because I don't have one that does that. Sorry. But this is the x, so you put an x there, and then you put in your function. Now, I'm going to pull it out the old-fashioned way, which is bars. We are never going to do anything with the stuff underneath here. We're always going to do y variables, so we're going to go over. We're never going to do parameters or polars, so we're going to take function. And I want y1. You should have learned that in pre-calc class, how to get y1 off the calculator. If not, you need to know it this year full. And then I want to do this at 1, right? Yeah, I'm going over it. There it is. Now, when you get used to the calculus, you'll like this notation that's here. You'll prefer it over the nderive. But right now, maybe not so much. No, it's the same with that one. I'll do that. I'll do that next. Okay, so I'm going to clear that. Now, those of you with 84 with the new operating system, this is what you're going to do, what you can do. You can still do it the way I just did it. Or you can go alpha, and then y equals, no, that's the fractions. It's this one. These are the shortcuts. Here's your change of base. So you do 4. Oh, I don't want that one yet. Not yet. Sorry. Nderive is 3. It looks just like what I just did. You put in an x for the denominator, and then you put in your function. Now I'm going to do the shortcuts, which is alpha, and then the trace button. I get all my y's. And you're going to want that. Trust me, you're going to want it. And this is going to be 1, and I get the same answer. But if you're an 83, it's not going to look like this. It's going to look like that nderive thing. And I'm going to come back and do the Inspire calculator in a second. So that's how you do the nderive command for the slope. Now, If you turn the page, one little Roman numeral 1 and 2 are just the directions of what I just did. Okay, it's written down for you. Now, for number 6, follow the directions. For number 6, you are only going to do, you're not going to do that little table of values and that pretty picture that we have written through that. That was just to introduce you. You are going to take these two functions, a, f of x is equal to x to the 4th. Guess what? You're not going to like this. And that's at 1, 3. You're going to do this by zooming, the geometrical way. You're going to do by end derive. And how do I know you actually used your calculator? You're going to give me all the decimals, because you're not going to get an exact answer. Neither will you with zooming. So if I get an exact answer like -3, I'll mark it wrong, because that's not possible. You have to change the settings. I'll show you how to change the settings. you want to change the settings. And then you're going to do this the analytical way. Understand what I mean? That's the limit. You're going to do that for this one, and you're going to do that for this one, which is the sine of x. Now, to do the sine of x, you guys are going to have to take notes on this, or else look at my smartboard. You need to know this trig identity. The sine of x plus y is the sine of x cosine y plus cosine of x sine of y. Because you cannot do pi plus h there. You cannot distribute the sign. You have to do an identity. In the old days, we didn't have calculators. So if we wanted the sine of 75, I would think about it this way, degrees. Sine of 30 degrees plus 45 degrees. Then if I use this little formula, I know what the sine of 30 degrees is. I know what the cosine of 30 degrees is. And I could get that information really easily, because we didn't have calculators. So that's the reason for these identities. There are other reasons in calculus, but you just look up the identities and get them when you need them. So there's no reason to memorize those. And then in 7, I give you a couple functions to investigate. Investigate them graphically, see what you can come up with, and don't forget to answer 8, because 8's the whole point of the lab, and it's nothing complicated. And I've actually given you the answer in this lesson today. The answer to 8 is somewhere in here. Now, for those of you who have an Inspire calculator, because some of you may have that. Now, mine's a CAS, so I'm going to add a new page. First off, this is cool. I'm going to add a calculator page. And those of you with, now, it has to be a CAS, though, a regular Inspire won't do this. You go under Algebra. Okay, you guys? Right? Algebra. We're going to expand. Doesn't matter. I do it. You could put all a new one, but expand. I want 1 plus h cubed. 1 plus h cubed. It'll give you 1 plus h to the 4th. So if you have a friend who has a CAS calculator, it will give it to you. You know, it's just multiplying 1 plus h times 1 plus h plus 1. That's it. Yeah, it does that. That's in the calculator page. But also, now, how do you get the end derived stuff? When I go to menu, calculus, and you want the derivative at a point. There's 2 ways to do it. This is one way. We're only doing variables of x. And what point do I want to do this at? I want to do this at 1. I can cheat. And there it is. Then I can type in my function. Yeah. So it's just like the 84. Possible because the CAS is more powerful than the regular 84. Did it work? Right, because it's far more powerful than an 84 calculator. That I know of. Write me a note saying you used an Inspire, because then I'll know. What was the other thing? Oh, now, I bet there's something else you don't know. I'll just put an X. The answered one. Okay, you guys? Also with an Inspire, let's say you forgot where you look it up, so you can actually type it in. And all those commands, expand, I can type it in. So notice it's italicized until I put the V in. There, now it's not italics. That means it's a command on my calculator. And so then you can do that, and I can type it in. I'll just make it X. So this looks like what it will look like on an 83, or 84 that hasn't been upgraded. And it'll do it for me. It'll tell me one. Well, yeah. Sorry, I'm not sure what the central diff is. I'll find that out. But on an 84, that's what, or 83 is what it looks like. Okay. Are you more clear about what you need to do? And you have today, the rest of today, which isn't, you got 15 minutes, which is actually a lot. And you have all class periods tomorrow. You can get back to your partner tests tomorrow, and we can look at those quickly. So you should get it done before you leave class tomorrow. Sure, because you should be part way done through it already. Because you have all of tomorrow.